In today's video, I'm going to be talking about Doppler effect, and this is genuinely a topic that just like I always study it, and I get so excited when I study it because it's so fun. It is just fun, and I think I made a video about one of the questions about this topic that came back in the national exams. It's on my YouTube channel. It's a very beautiful questions, or at least I find it as very beautiful. So you guys can definitely check that out. And after we discuss this topic, you can go back to that video, or you can find that question and solve it and see if you've understood very well or not. But let's just dig deep into this video. So Doppler effect, now we're going to talk about Doppler effect. Okay, essentially before I talk about this whole thing that you see over here, I'm going to talk about the definition. Doppler effect is an observed change in the frequency. So it's an observed change in the frequency. When there's a relative motion, there needs to be a relative motion, guys, between the source of waves and the observer. Okay, so three main things. Doppler effect, it's an observed change in what? Well, it's in the frequency. You don't say in the speed of the sound. No, in frequency. When there is what? When there is a relative motion between what? Between the source of the waves and the observer. Okay, guys, when you are first introduced to Doppler effect, you are also introduced to this rule right here. Actually, the rule goes to remove these negative signs in front of them and just like writes a plus minus in front of them. But I would like to go and like talk about, like, not talk about, write a negative sign in front of that. But I'll tell you why I wrote that negative sign like by the end of the video, or not by the end of the video, just like later on. Okay, look guys, Doppler will occur if there is a change in the frequencies. Okay, let me just talk about it. This is the observed frequency, okay? When there's a change in the observed frequency, that's the observed frequency. That is the original frequency. These are the speed of sounds. This is the speed of the observer. I've written it down. This is the speed of the source. When there is a relative change, when there is a change, and they're not equal, they're different. Like here, the observed frequency is more than the original frequency, whereas here the observed frequency is less than the original frequency. It will not occur if they are equal to one another. Okay. By the way, Doppler also is it's a phenomenon common to all waves, including electromagnetic waves. So do not think that, okay, it's just for mechanical waves. No, it's not. It's not bound only to mechanical waves. It's also a property, and it is common to not property, but it is common to electromagnetic waves as well. For example, like visible light. All right. Hold on. So I mentioned that it occurs when these are happening, and doesn't occur if these are happening. It also does not occur if the source and the observer, they move in the same direction at the same speed. So there needs to be a change there when the source and the observer, let's say they are in the same place, like the observer is in the source, in the car, let's say in the observer's and the source's car. So let's say this is the car, and it has a siren, let's say, and the observer is in the siren, is in the ambulance, let's say. It will not occur. Doppler effect does not occur in that situation because both the source and the observer, they move in the same direction and at the same speed. Like, what do you expect? Like, obviously there aren't going to be any Doppler effects happening, okay? So it won't occur. It won't occur if that's what's happening. When the source or when the observer is stationary, when one of them is stationary, by the way, when both of them are stationary, obviously Doppler effect will not occur, okay? That will not occur, okay? It will not occur if both of them are stationary. Come on, like, common sense, I'm afraid. But it can occur if one of them is stationary but the other is not, okay? But if both of them are stationary, nope. If both of them have the same speed and at the same moving in the same direction. By the way, it could be that the source and the observer are not even in the same like place or like same position, but simply in like two different cars moving the same speed in the same direction. there won't be any Doppler effect. By the way, guys, just know that. Don't ask for like, not don't ask. Don't be curious about real life scenarios because there are a bunch. You can actually search those on ChatGPT. But as I'm here to say, like, if you see that, that. If you don't see that, that. Okay. And so that's why I'm not going into detail to bring examples and just simply go into details. But anyways, Doppler does not occur if these two are equal. When will these two be equal? Well, these two will be equal, let's say, if both of them are stationary simultaneously, or if both of them are moving in the same direction at the same speed. No, just will not occur, okay? They will be equal, Doppler does not occur. Okay, and then this one, look, only lambda, which is the wavelength, and frequency change and not the speed of sound. This is very important, guys. The speed of sound does not change, okay? They compensate one another in such a way where the speed of sound is constant, okay? So they, for example, let's say if the frequency gets higher, the wavelength gets lower, and obviously the speed of sound then will remain constant. Okay? It's, so they're inversely proportional, but the quantity, which is like v equals to, the equation v equals to f times lambda, the v will still remain the same. Okay, guys. So I talked about this. I also talked about this. I also talked about this and this one as well, but this one is interesting. This was the note that was very, very important for Wizard exam and the national exam, and it came back, okay? Look, guys, when the source and the observer are moving towards each other, the observed frequency is more than the original frequency. It's approaching. When they're approaching one another, also know that pitch and the audible vibrations also increase. Obviously, because I've told you, pitch and even audible vibrations, like, they are dependent on the frequency, and the frequency gets more, and so do they. Also, if they move away from each other, then the observed frequency is less than the original frequency, and these will also decrease. Guys, the thing about the question from Wizari was like, they went ahead and they didn't say that they're approaching or they're moving away. What they simply did was they gave us the observed frequency. They also gave us the original frequency, and they were like, okay, like, you were going to compare, now going to compare the original frequency with the observed frequency. And I believe in the question it was the observed frequency was more than the original frequency. So you would assume, and you would need to assume, that they're moving towards each other. That's why I found it so fancy. Like, I really genuinely found that question very fancy. Maybe I haven't solved a lot of questions like that. Honestly, that was the first time I solved a question like that. But because I knew the core concept, which was simply like, okay, observed frequency is more than the original frequency. That means they're approaching, and I will deal with that the way they are, okay? Beautiful question. Maybe I'm over-exaggerating about that question, but honestly, I just found it so beautiful. Anyways, this was everything you needed to know about Doppler effect. If there is something that you guys think that is worthy of being mentioned that I haven't mentioned, comment section is open. You guys can ask, and everyone will benefit from that. All right, now that's it. That I have checked my notes, 2 guidebooks, and the book, and this is what I came up with. Okay, guys. Now, how to determine the signs, how to know what the equation is going to be like. This equation right here. That's the fun part. I really like that. Okay, that's the fun part. All right, guys. My teacher back in school, he would always tell us, always draw a line from the source towards the observer. Okay, always. Okay, let that be the first thing we do. So this is the source to the observer. The red line would be this way. And this is the source. The red line would be obviously towards the observer, this way. This is this way. This is this way, all right? So always draw a line towards the observer, always, okay? And we did that. Okay, let me just, hold on. And that's what we did. Okay, all right. After that, he told us, now, okay, if he said to everyone in my class, if this red line, we're going to be comparing this direction. Obviously, we're knowing that the observer is walking this way because, it says it's walking away from the source, okay? And the source is moving towards the observer, but the observer is moving away from the source. So obviously, we know the directions of each one of them, guys. He said that whenever the red arrow is in the direction of either one of them, we're going to add a plus. Okay, I'm going to show you. Don't worry, I'm going to show you. So the observed frequency, the original frequency, and then how do we know if we are adding a plus or a minus? Go back to the rule. There's a minus right here. Okay, I put a minus right here. If they're both in the direction of the red line, both of them, this one is in the direction of the red line, and so is this one. So for both of them, you're going to be, for this thing right over here, you're going to choose the plus. But obviously, because the rule has a negative sign in front of it, the negative and the plus, they give us a negative. Okay? How interesting. I don't know if you're getting my point right here, but it's very helpful. Very helpful. They're both in the red, so the both of them, these two, are both in the direction of the red line. So I will be I will be writing a positive sign in front of them, okay? But because the rule already has a negative, the positive and the negative, they make a negative, okay? So that's the way to go. And then you plug in everything, you find it. Very nice, okay? And let's try this one. Very nice. Okay, so you do this. All right. This is in the direction of the red line, but this is not. This, for the observer, I will add a plus, and because of the negative sign that is already in the equation, with the plus, it gives us a negative. I will give this one a negative, the negative from the equation, and this negative, they give us a plus. All right, they give us a plus. All right, I'm liking this. Are you guys liking this? I hope you are. And then, again, try it for this one. This is not in the direction of the red line, but this is. Okay? All right. This is in the direction of the red line, so this gives us a positive with the negative from that, so that's a negative. This gives us a negative, negative, and negative. They give us a positive. So there's a positive here. And lastly, for this one, both of them are in the opposite direction to the red line. So you can already assume what I'm going to get. Yep, you're right. I'm going to get a positive for both of them. And then you're just going to plug in everything. You're going to get the right answer, inshallah. And that is it. That's honestly it. I don't want this video to be too long, but this is essentially what is essentially everything that you need to know about Doppler effect. Honestly, there is something else, but I probably need to make a video about that if I have time, but I just want to tell you about it though. So basically, sometimes in the question, if the question says that the audible vibration is percentage greater than the source of the vibration, you're going to be doing this, okay? F prime 1 plus the percentage F. And then it might say, like, if the question says the audible vibration is certain percentage less than the source vibration, it will be like F prime 1 minus the percentage. Why is this doing this? Guys, you could already assume, like, for example, let me tell you, like, wait, let me see if I can find something with that idea. Yeah, I can actually find that one. For example, it says a Formula One car moves from the fixed observer who hears the sound of the engine with 20% reduction of its original frequency. You can already tell that it's going to be this one. f observed is going to be 1 minus, because 20%, that would be 0.2, because 20% is 0.2, and then you do the math, which is going to be that f prime will be 0.8 of the original, okay? And if it was plus, you're going to do that. Guys, this is it. I don't want to make the video too long. Bye.